Okay, seems to work now again. Yeah, sorry for that. Didn't miss too much. We just essentially fixed the tab view, and now we are continuing with our game object tree, which I renamed from scene tree. Okay, for all game objects, here we go. I think we will just start iterating over each game object, and let's just start with a first flat list of the top level game objects. And let's see if this makes sense. So we have a text shader program, which is already correct actually. But I think we can do that only once, not necessary. Updating the text makes sense. Yeah, why not? And we have the current game object, and it is... Doesn't it have a name? But it's actually correct. We need that. Otherwise, how to display it? Okay, that makes sense. This is the text mesh then. We're binding the correct texture, that makes sense. And now the interesting thing is that we now have a, let's say, the age offset is 8 and the V offset is, let's say, 64. So we start 64 pixels from the top, and so we will start with the age offset all the time, and we will then go V offset plus, I mean, let's just say this is the go index 0 times plus go index times, let's say, 24, and that should now give us hopefully a nice list of all the game objects. And I mean, let's see if that works. We should see one game object now. Nothing more, nothing less. Okay, that's fine. Yep. This is the sorry. This was not the problem, but this was the problem. Okay. Game objects is empty. Okay. Let's see if we get something here. Ah, yeah, I think we don't render it. I think we... I mean, we also don't... Okay. Create test game objects. But I think it's not called. It is called. Okay, interesting. Ah, yeah, it's never added. It's actually never added. So we have editor state, game objects, pushback, the hero game object, and to do add more. So render, game object tree, and we need to also render the text, right? Ah, yeah, okay. So the old size is 0, so this is now when we're updating the text. Okay. Okay, yes. So the old size, I mean, by 2. This is stupid. But that's fine. I mean, we need to find that, because this is a source of constant inconvenience. Do we have the text mesh? What is the text mesh, you know? This is the text mesh. Okay, yep. This is the text mesh, and the text mesh does have no positions. Okay, so I think the problem is the actual creation of the text mesh. So where is this created? Here it is created, and this should actually work, right? With this long placeholder text. So render text into the. So we have something here that's nice. That's okay, and the text is this okay? Yeah. We create the text mesh. We have all kinds of things here, and the text mesh now has okay, I mean, it has no positions, and but it does have an index count. Yeah, but it does have a vertex buffer. Interesting. Okay, but I think it's, I mean, it's fine. It's not, I think it actually has something in it. This is just 0 here, but it has an index count, right? So okay, so then let's see if this is now updated. This is the index count. What is the text here? Oh. Oh. Ah, yeah, because it doesn't have a name. Okay, yeah, that's, oh, I think I see what the problem is. So this is the old size. So, but this is the new size. No, but that's fine. Okay, I see. Yeah. I think I see now what the problem is. And the next time, old size was 0. Yeah. I think this is actually not really relevant now. I think you can try to live without that actually. Because originally the actual buffer was created big enough normally, right? So against the actual original vertex buffer size, because as long as we are within these bounds, we're fine. And we will probably just store it in the mesh anyway, yeah. Yeah, and we will just do it like this. Creation index counts. And so if new size bigger than the creation index count, I mean, we don't even need this. If new count, yep, I think that's fine. So now we just need to make sure that we actually fill this. So when we create a vertex array, no, not so here we go. And so now yeah, and we just do this as well. Or maybe let's do it that way so we can move it around, otherwise dangerous sequential dependency. And I think we can try again. Yeah, but still, it's not really working, which is clear because we don't have a name. Haha. Create test game objects, and we need to give it a name. This is our hero. Here we go, here we have our hero. So, I don't like the position of this here, of the title, but that will also move to 8. And now let's create test game object. Let's create a few more. And we will create an enemy 1 go, enemy 1, enemy 1, and we give it the enemy mesh. Let's see, I think this does not exist, but anyway. So 1 is at 2, 5. Let's create a second one, and then we will deal with the children of these game objects, and we will have child objects there as well. This is enemy 2. Yeah, I mean, let's see if that just works right out of the box. Hero E1. Yes, I think I know the problem, because I think we do not actually increase the Go index. Here we go. Here we have our free game objects. Now let's say we have something attached to one of the enemies. Let's create a small little whatever. Here's a drone. Enemy 1 drone. One drone go. And this is the enemy 1 drone. And it has a drone mesh, which does not exist anyway, but we don't care for now. And this is now actually no, because now we say this is the enemy 1 drone go, children push back. We could also make a more nice function here, but yeah, let's keep it for now. And nothing will happen now, but we will try to make it happen. So let's create a function render game objects tree recursive render game object labels render game object item no, game object recursive. Let's do it like that. So we want to give it the editor state, and we want to give it the current root object. And you give it a null pointer. Yeah. And this is a game object pointer. And this is called the root game object. So now we can just we will just create one, right? We will just take the one from the editor state root game object. and we will, I mean, essentially we'll just create it in the init editor function. Editor state, editor state, game objects, no, root game object equals new game object, and root name equals root. That's okay. Root game object creation holds all real user created game objects. So otherwise, so I think that should traverse everything. And we need, of course, the editor state text mesh. I mean, I don't really know. Of course not. Oh yeah. Whatever. Editor state text mesh. Editor state text mesh. Yeah, maybe it works. Yeah, but this is of course not really correct now. I think those indices are wrong now. Yeah, and it's not working at all. Oh yes, and we have to create test game objects. They all have to go under the editor state root game object. Children, push back, hero go, enemy one go, and enemy two go. So that might then just as well replace the list of game objects, but yeah, I guess that's fine. Yeah, I mean, it's still not working as expected, but I have a suspicion why that is. Recursive. I mean, let's look into this. So the first one is the hero one, I guess. The hero, yeah. I mean, that makes sense. And if we enter now for the hero, so the root game object is now this hero object, I presume, yes. This does not have any child, so that's fine. So we come back here, we are now in hero 1, I guess. And now it's interesting because hero 1 should actually have a child. And it does not. Why? This. Oh, okay. This is interesting. Enemy 1 go. I was a bit stupid. And now this is the enemy. And the enemy should have a child. Here we go. But of course, we need to probably pass on the child level as well. I think this would not work now. Yeah, because it's just on the same level. So we need something. We need some V level offset. So this is the general offset plus the V level offset. And the V level offset is yeah. No, I think we can just call this the lever plus lever times 24. And the lever is actually this is just a lever plus 1, right? Yeah, I mean that could work potentially. And we start at level 0. We probably need to watch this. How this really turns out. So now we are in level 1, which doesn't count because it doesn't have a child, or does it? Oh, it's enemy 1. Yeah, that's fine. Okay. Yeah, however, so this is now level 1. And now it has a child. Yeah, so this should already be rendered differently, right? So this would be now level 2. But it doesn't have a child, so that's fine. So now we're back at level 0 and we render. Okay, yeah, that's more complicated than that. So let's call this the V level. This is the vertical level, and the vertical level is always is always +1. Oh, how do we do that? Yeah, I think we can say increase the v level, and then when you recurse in, we increase it furthermore. Yeah, because you need to get track of the vertical height. Of the whole tree. Yeah. So our v level is now 0, right? Yes. Now it's in any case 1. Now it's 1. I mean, we need some kind of, yeah, I mean, it's actually not that complicated probably. We just need some kind of invocation tracker. I mean, this is just the invocation number, invocation counter. And I mean, the invocation counter is just always, just always raised. No, we don't need that, right? So we have the invocation counter ++, and we just have invocation counter +1. Or is that enough already? I mean, let's see. Maybe it's a little bit double whammy. Whammy. Let's see. So the invocation counter is now 0, which makes sense. So we update everything. It was once, now it's twice. I mean, let's just see the end result, I guess. And yeah, I mean, it's not that bad, but also doesn't really make sense. We just have the last stage always. That would make sure that even if we have a child here, the next object on parent level would still be below that child. Yeah, not so easy. Not so easy. It's not so easy. Yeah, we'll get there. Maybe this is really a bit unnecessary bad. Okay, interesting. Okay, yeah, so now we got this. I mean, let's think this through once more. So we need to, so we want to keep track of verticality, and so vertical offsets and horizontal offsets. So the vertical offsets definitely grow with each invocation, right? So each invocation must move the vertical offset down. So that makes sense, okay? But then per per child layer, we also need to increase the horizontal input. So if this is a child, so these are now all rendered with the same invocation count, and this is already not correct, right? So I think we need to already do this here. Do we? No, and then we just do it like that. This really. Okay, so let's once more think this through. So we come in. Let's see if this would not be recursive. How would you do that? Yeah, then we go. Yeah, so we need an invocation counter that is actually reflecting each object. Okay, so I think that makes sense. So we increment the invocation counter indeed. Next, what we do is we increment it double, but this is also not okay. I think we need to analyze this better. Let's probably watch it. So we start with the root game object. And it has three children. So the first one is the hero. So the hero is rendered, that's fine. And then we make sure that the next child is also correctly rendered. So now when we enter this, we are at invocation counter level 2 already, which is already wrong, kind of. I think what you would actually need to do is probably make this so we render the hero, we go in, this is invocation counter 1 still, so we're still on the first level, that makes sense. And there is no child, so that's fine. So now we are on invocation counter 2, 1. Yeah, no, but this doesn't make sense, or does it? No, what if we just what if this is I mean, if I was rendered, I will just, after myself, I will just do that. I mean, what he could do is have a static variable here. Static int invocation counter equals 0. Each time we start from the root object, we set this to 0. Otherwise, we will just increment it with this static variable here. Yeah, I think that makes much more sense. That sounds natural now, because you only invoke it after a concrete rendering, which sounds super correct actually. Not only correct, super correct. So we still have invocation counter 1. This has no child, fine. Okay. Next one. Invocation counter still 1. So we render the next child correctly. We invoke it. We are here. This one has a child. I think it is correctly rendered now. Perfect. Oh yeah, I think that's now working perfectly fine. I think this is perfectly fine. Here we go. Enemy, the enemy 1 has the enemy drone, and then we have enemy 2. Perfectly fine. We just now need to tag it in as well. And I mean, for all the children, we have the same like horizontal offset. So because this does not grow monotonically as the vertical offset, but sometimes it grows and sometimes it does not grow, and it always grows only when we go into the recursion. Yeah, I mean, let's try this out. I think this should work. Horizontal offset. Horizontal offset variable. Horizontal offset varying. So we have an incoming horizontal offset varying, and we just remove, we just increase it, and this is now horizontal offset plus horizontal offset varying. I'm not totally sure, so the horizontal offset varying is for sure 0. We will watch this. So this is the hero object. And the offset varying, just in case, would now be 1. Which of course, oh no, it's not, because +1. And anyway, I think we will offset varying times 8. And yeah. So the offset varying is now 1, but we don't have a child anyway, so that's fine. So we're back to offset varying 0, which is correct. We don't want any offset here, but now we want 1 because now we are the drone. So now the drone should be offset. Drone doesn't have any child, so that's forgotten. And here we are now back at offset 0. Yeah, I mean, I think it should work, and it does. Indeed, it does. How nice is that? Yeah, it's working. It is working. And let's probably double this up. So yeah, let's see if it really works. Let's see if it really works. Let's see if this really works. Because now let's go one level deeper. Enemy drone. Device, go. Enemy one drone. So this is now the drone device. Device mesh. And the enemy drone, go, the children, and it gets the device, go. So let's see, because now we should see 2 layers. And here we go. Look at that. Very nice. And let's now say we don't want to fully expand all the nodes. So what you could do is we could yeah, I mean, I think the best thing is we just edit here. I mean, it's a little bit expanded in tree equals true, so we can set this to expanded in tree is false. Render game object cursive, indeed it is. If go if root game object expanded in tree, just do that. I'll just render this. And we will not even go into the children. And I think no, I think it's actually no, is it? Yeah. Yeah. I think now we should have the same result. But if we now say that render test create test game objects, if the enemy one drone go, if the enemy one go, let's make it like this. Expanded in tree equals false. Let's see what happens. Let's just see what happens here. So, but this is expanded, so we go in here. No child. Fine. Next one. This is the hero go. It is rendered. We're going in here, but it is not expanded in tree. We still no, I think this doesn't make sense because now I think it's 2 times the. No, it's fine. I think we still, do we need it? No, it's the same. This doesn't have any children. Yeah, it's enemy one twice. Yeah, that's what I thought. I think actually this is stupid. I think this is it. If go expanded in tree. We recurse, otherwise we don't recurse, right? I mean, I think that's just what it is. Yeah, and now if we do that, enemy one drone go, we should still see the first level but not the second one. Yeah, and that's nice. And I think if we say if hero go is false, it doesn't change anything because the hero doesn't have any children here anyway. So that's fine. Yeah, okay. That looks quite robust. So the question is, if we say the game object's actually not expanded, We could try to make an expansion by clicking on an icon, right? Yeah, I could try to do that. Could indeed try to do that. Let's see. Render game objects. So, because now we can go into the tree. You can also grab some water. And we will so we will now render some icons. Some tree icons, e.g. for expanding. For now, it's just those little dummy rects indeed. And we will also move this into the recursive function, of course, because we need to do this for every item here, and we will probably put this in here. Render an expansion icon. Okay. And now I think the rotation matrix, yeah, maybe we need it. But we'll just keep this for now. So now the actual offset is, let's say, 24. And now we will set this matrix to 8 plus h offset varying times 8. And this is the v offset plus invocation counter times 24, makes sense. C is 1, why not? And we just make it small, that's just 16 by 16. Let's just see how that works. Oh, and we need to bind different things here. Binding the texture and binding the... Yeah, so we need this now. And we need this, no. This is not super perfect here, but we'll see. Let's see if something is coming out here, or we are completely lost. Yeah, I mean, it's not that bad. I think there's just something off the blending. It's probably enable blending false, and I guess enable blending true. Yeah, I mean, the text for sure needs it. I mean, it's not that bad, right? I mean, it's okay. Create test game objects, and I want to have the enemy one drawn actually being expanded. I know this won't work, and I need the enemy one go. Yeah, I think that is fine. I just want to see if that still works. Yep, okay. And this is probably 12 by 12 or even 8 by 8. And let's see how that looks like. Yeah, now we have these small icons here. I mean, I don't fully understand why it looks so bad. I don't understand. Okay. So every second one is actually fine, but okay. No, that does not work. So this is it, but then we move it up 4. I just want to line that a little bit nicer vertically. Yeah, but now I do not understand why we have the blending issue. Is there some blending false? No. Why would that be the case? Enable blending false. I would not understand it. Can get rid of this for sure. I mean, we need to pull this in anyway. That makes sense. Oh, is it still the wrong shader program sometimes? all the things are rendered for one tree item, we can increment the invocation count, so we make sure following renders are moved vertically down. Only recurs if this node is set to expand currently. Okie dokie. Let's see. I think something must still be off. No, now it's working. Okay, good. Yeah, I mean, this is a little bit strange. Ah, yeah, okay. Yeah, nice. I think that should be it. Yeah. So let's now be super clever and say if go children size bigger than that, only then we render the marker. So we should only see now 2 markers. Step by step, we get there. Here we go. So now the question is, how can we best track the mouse position? And I think I already have an idea. I think we will do it again, very similar to how we do the tracking of the tabs, because we can just bake in the rendering bounding box in the tree, and then we can just check against that. Guess we'll do that. Yes. Okay. So let's go into the game object. Here we go. And we will just give it a bounding box. This is the game. This is the tree bounding box. So now we say check main tab inputs. It's nice. We say now void check game object tree inputs, editor state, and I think we can start with copying it from here, and then we will adapt it. So the vertical offset is 64 first of all. The horizontal offset is actually, I would say, 16. Yeah. And yeah, let's not do that for now. Yeah, yep. We can now say these are the visible game object tree items. And this is a tree item. It's actually a vector of game objects. And every time we render the game object tree, we will clean it out. So we will no edit the state. These are cleared. Then we fill them in. Editor state visible. Push that back in, and yeah, because that was rendered, so that's for sure. And yeah, I mean we can even we could even do it like only with those, only those that have a child and they're actually clickable, right? Yeah. Yeah. And here as well we do set go tree bounding box. Equals, what do we have here? We give left, top, okay, left, top, right, bottom, right? So the left is actually, of course, this here, 8 plus h offset varying times 16. Then we have top. No, top is actually yeah. This is the v offset plus invocation counter times 24. This is top. And we have right. Right is 8 times h offset varying times 16 plus 8. And the bottom is float v yeah, let's see. I mean, this is actually the same, I guess, yeah. So if you're mousing over, we'll do a standard cout hovering tree item. Yeah, I mean, let's see. No, that was a bad idea. I should go into edit mode, to debug mode. I meant debug mode is the mode to go. So I mean, let's again check. So now what we would like to see is we are at 5, 3. Okay, yeah, that's interesting. So that's between 5 and 14 makes sense. It's 8 long, and it is 113 to 121. So it's 5 to 13, and it is 110 to around 120. Which makes sense. Yeah, first of all, I think that this is not called anyway. Check game object inputs. That's the first thing. Okay, nothing's happening. Let's see. So how many do we have? We should have 2. Yeah, 2 is good. Let's look at the bounding box. So left is 8, top is 88. Right is 8, that doesn't make sense. And the bottom is 96. I mean, it's just wrong. So what is the actual virtual offset? So it's render game objects recursive. So it is actual 64 plus 64. I think it's actual another 64, right? So this is around 64 here, yeah, and this is 24. So the virtual offset. Okay, from here to here it is of course 64, but that is actually 64 plus 32, then yeah, okay. 64 plus 32, it's 96. That's the first thing. The second thing is this is just totally wrong. yeah, this is just totally wrong. And times 24. And yeah, I mean, it's just 8. I mean, yeah, let's just make it a little bit bigger. Minus 4 plus, no. Oh yeah, let's see. Let's debug. So the tree item has a tree bounding box of no, it's so it's 4 to 20 and 88 to 98. I mean, that's not so bad, but oh no, sorry, I think it's actually 32. Yeah, that's fine. So like if you're really in the middle, it's 7 and 117. But oh yeah, here we go. Look at that. Seems to work. Nothing's happening. Nothing's happening. No, that doesn't work. But hey, I think it worked. Okay, it's really only dead center. Enemy one drone. Okay, so when did it work? No. Okay, it's a little bit down. Yeah, so we just, yeah, I see. Okay, so in reality it is between 112 to 120, so this is the 8 here, and what we get is 88 plus 32 is 120, and mass y equals 106. Okay, once more, slowly. So what we want is 100, let's say 112. And what you get is we could also just say what is it when we write. So what you get is 121. So I think if we move the offset by 8, it could actually work. Yeah. Okay. Enemy 1. Okay. It's probably 0. Yeah, I don't fully get it now. I mean, I know it's super small, but normally it's fine, I guess. Now it starts. Ah, come on. What did I do? But that is fine. I think that's fine. It's no longer doing it, no longer doing it. It's starting. So the mouse X is 29, the tree atom is, yeah, because it's in set. So we say it starts from 112 to 122. Let's just make sure that this makes sense. 112. Come on. 112 to 122. So I think the actual offset should okay, so that was early. The mouse was 89, but the tree atom starts at 88. I think the 24 is actually fine. But the age offset is worrying me because So the tree item starts at 4 and ends at 20. And 88. It's 112. Yeah, I mean, that's fine. So if we say render game objects recursive, I mean, we can just no. I mean, let's make a small, super small icon. Let's say it's 16 by 16. And let's make it that way. 1 pixel is fine. And if we copy that layer and we transform it and we export that as expand active, now we import both. Okie dokie. Render game object recursive. No, I don't get it. I don't get it. Yeah, it's just the same. Whatever. Do this. Okay. This is pretty interesting. This was a small typo. Yeah. Doesn't look that bad, right? So so we need to say render game object recursive. Yeah. Yeah, and it's okay. Check. This is actually, let's try this out now. This is actually a game object. Hey, it actually works already. 1, 2, 1. Yeah, okay, look at that. It's nice. So we close everything. We open everything. And yeah, I just want to show it somehow that the hover is really nice. So render game object recursive. Edit the state, current hover, expand that equals go. We'll just call it active. So just we have a better visual indication here. I mean, it's not. The left side is okay, the right side is not good enough. I think the left side is okay. Okay, should just expand it to the right a bit more. I would say plus 24 for now. Yeah, makes sense. So now we will not do that, but if go expanded in tree, active instead. Yeah, the top. Yeah, that's also not good. We need to somehow, I don't know, -8 plus that, and plus 8 is fine. I think no, that could work. Okay. That's good. Yeah, I mean that feels natural, right? Yeah, that feels totally okay. So I think this is a good place to stop for today. I think we had some nice success here. Our tree is like very basically working, and yeah, let's call it a day for now. And oops, see you then in the next episode. Thank you.